Hello everyone from Tony the Scarred Ghost, and welcome to this video where I will introduce you to Hybrid Hand Interactions open source plugin, which lets you interact with real objects from your mixed reality headset. So in this video, I will show you what the project is about, how the open source Unity project is structured, and how you can modify it to use it in your own project to create your own interactions. So let's start. What is hybrid hand interaction? So it's an open source plugin I created because in this moment I'm a bit obsessed in finding a way to make the real and the virtual world operate together. After having played with the scene setup by Meta, I started wondering if, apart from understanding the main features of your room, if it is a way also to understand what are the objects you can interact with. It would be very cool if I could take this bottle in the real life and see it in mixed reality, I don't know, as a tree, as a firework, as a fire extinguisher, or whatever, and grab it to have an interaction with a real element while having the interaction with a virtual element. Currently, in mixed reality headset, this is not possible because we don't have objects tracking. So the only way you can do it, is by putting like a Vive tracker or Pico tracker or equivalent on your object, have a model inside a virtual application so you can use it. But I was wondering, is there a way that we can have this in a more natural way? We have now hand tracking. Can we have like a simplified way to interact with objects without having to add additional hardware? And my intuition was exactly to try to use the hands. So the moment I grab an object, I create a relationship between the pose of my hand and the pose of the object. So if I translate my hand, I also translate the object. So the idea I had is, can I create a framework that I can say where the objects are in the scene so that when I grab them, I can relay the position of the object to the position of the hand. In this way, I can track the object without having the need to use Vive trackers or equivalent, because my hand acts as the Vive tracker. And now all the major headsets are all tracking the hand. So to do the operation that we need to do, we have to do two things. One is about defining where is this object in my room. So creating the collider around it so that the virtual world knows where the object is. Because as I said, the headset cannot detect the object. So we need to say what is the initial position of the object. And I want to do it in the most natural way possible. What if I could just take my hand, do this, and by the radius between my the distance between my two fingers understand the radius of the button. So it will be very, very handy that there is an object, I do this, and I immediately place the object in the virtual scene. And that's the phase one. And the phase two is having the interaction with my hand that can grab the object, and grabbing it in the real world grabs it in the virtual world. So I can move the real button to move, for instance, the tree, the fire extinguisher, whatever, that is the virtual equivalent of this button in the virtual world. So also the repository is divided in these two things and are functions and facilities for these two different purposes. So at this point you may be wondering, but Tony, does it really work? And the honest answer is yes and no. It depends. So the problem is that on paper, in theory, everything is works, everything is perfect, but the reality is a bit different. So first of all, let's take this example of this bottle again. So you have it here, I take it with my hands like this. So there is a problem, as you can see. You're seeing these four fingers, but you're not seeing my thumb anymore. So the tracking camera of the headset have the same problem. When I grab the bottle this way, they don't see the thumb. And so instead of putting it here while tracking it, maybe they move it here or here or here. And so the detected position of the bottle is totally ruined because I don't see exactly anymore this pinch remaining stable across my movements. But I started seeing the button moving this way because the thumb is not tracked correctly. So luckily, some companies like Ultralip now are starting also to optimize the hand tracking for objects management. But we're still in early days of this. So that's a problem now. Second problem, I would say, is also the fact that the hand is very flexible and sometimes you do lots of micro movements that the headset doesn't see or they don't track it correctly. And especially while doing the tests for this plugin, I noticed that you also do micro movements with the objects you manage. So my assumption is that you take the object and you move it this way. So the movement of the hand is the movement of the object. But for instance, you see while I'm doing this, I'm also slightly maybe bending my hand while doing this movement. And so I break the relationship there should be between the bottle and the hand that one moves together with the other. Second thing, as you can see, for instance, the bottle is slightly swinging. That it's perfectly okay in real life, but in this case again, I'm moving the reference system. So the real object is moving down, but the virtual object is not because I'm attached it to the hand. So all these things make sure that tracking an object this way doesn't always work. But still, whatever I did is a good foundation for a system of this type, and it can be improved over time to taking care about some factors. I noticed that for now it's especially good if you don't need a perfect tracking. Like, I don't know, you want to put some clouds moving, floating on top of the object, you can still do it even if the accuracy is not super perfect. As I said, anyway, there is also the problem that this is an open source plugin I did, let's say, in the free time. So, of course, there is room for optimization, code polishing, etc. It's very modular. I try to write good code, but still everything can be improved. And we can also work on something to make this tracking more as accurate as possible. Maybe also adapting it to different headsets. Maybe someone has some um, possibility of object tracking. Who knows? Um, One thing that I want to say anyway is that this project, if there is some company that is interested in sponsoring its development, of course, I'll be very happy. So instead of just working on it once in a while when I have time, maybe I can dedicate more time to try to polish it and make it compatible with more systems. So in case you're watching this video and you want to donate for this project, head reach out to me or donate to my Patreon as you want. It would be good to have sponsors for something like this. And now, after this little commercial, let's start digging into the technical stuff. This is how you will find the project after you have cloned it from GitHub. So in case you don't know where to find it, in the description, by the way, I put a link to the GitHub project so that you can know where to download it. You can clone the main branch. The develop is the one where probably I will do some work before it becomes more official. So as you can see, there are a lot of packages and dependencies that I put here. And then there is the samples folder, which is the one for where I put the sample from XR Interaction Toolkit and XR Hands because I'm using them as a facility to show the hands and do some interactions. It's much easier to start from the samples than creating everything from myself, even if it's possible. And then there is the uh, other dependencies, and from these folders you may realize that I'm using URP. So it's not mandatory to use URP. This is something that I'm using because this is mostly a plugin for standalone headsets, so URP is ideal, but in case you need, you may even change it. All my work is in hybrid hand interactions folder. And in this folder, there is all the scripts, all the scene, everything that you may use. So I separated here into scenes and Unity package because the idea is that if I have time and the resources and there is interest in the community in this package, I will do a better work in creating just a Unity package that you can import via their package manager, maybe thanks to OpenUPM or something similar into your project. While the rest of the project is just to give you a demo project. So I've not finalized this work. You see there is no JSON of the package, but the structure is very similar to the one of a package. So the idea is that porting it to the package should be rather easy. Inside the scenes, let's go here before, you have 3 demo scenes that show 3 different functionalities of this package and the related material used by the scene, with also some handy prefabs. Then in the Unity package, you have the core technology that I'm using. The editor folder is mostly about editor scripts, which are not very interesting, to be honest. And then here you have the real deal. So you have colliders management, which has some logic about colliders, as the name says. Very important is especially the ArcPlanes Collider Manager. So let me go maybe give you an overview of every script. So Collider Management include the broadcast collider events. It's just a helper class where you have an object with a collider that can broadcast its own trigger, enter, exit, etc. events to some other game objects. This is very useful because in some cases you have, for instance, you have the hand interactor that will have some colliders it has to control what they're doing. And so this function let me broadcast events from every collider to like a brain that can analyze the data of this collider. The ArcPlanes Colliders Manager basically takes the Planes Manager or AR Planes Manager or something like that, the AR Plane Manager of AR Foundation, to and make colliders out of that. So I don't want to rely on the user creating a prefab and assign to the airplane manager. I want to create my own colliders with rigid body, etc. So what I do is I register to the airplane manager, and for every found plane, I put a collider. This can be useful, for instance, when I will place the objects, as we will see later in this video. The common folder has some helper methods and other stuff like that, which you can see from the comments and see how it is. The data storage is about storing data. Sorry if I say a lot of like obvious things, but it's about like has some facilities to save basically string data. Actually, it is versatile. It's not just for strings, but in this case, I use it mostly to save JSON files. Sorry, JSON data. So you have pairs key data, and the data can be of various types, as you can see. And you can store it into whatever you want. I implemented it inside the player path. So basically what I did in general for many of the data structures I created either an interface or a base class or both, so that you can extend every system that you want. So the idea of the data storage in this case is, as you will see, you will place some objects that you want to save their position or use it in future sessions of your application. So you have to save this session. And I didn't want just to hard code that you save it in the player pref. So I said, okay, I created data storage. I personally save in the player pref with the player pref data storage, but you may create like a local file data storage. So you just extend data storage and you save a file with system.io methods. So this is how I did many things, interfaces so that you can expand. So data storage is a facility. And let's go then. Another facility is MVP. So I don't know if you are aware of the model view presenter pattern. Basically, it's one of the patterns to which you can decouple some data with how it is visualized. So there is one of the strategies called MVP, model view presenter, and here I created some views. So I'm not going to explain here all the model view presenter, but long story short, I'm abstracting the view or the visualization of data. So for instance, I have let me take an example, the text string view. So I have a string and I show it via text mesh pro. But this is an abstraction. So you see that inherits from value view string. And I can have another abstraction of value, another implementation of value view string, which is, I don't know, not text mesh pro, but original text, UI text, logic. So when you're going to write the data on UI, you don't care. You have the UI manager that basically say, oh, value view string, you write the string. But he has no idea if the value view is a text mesh pro string view or is a UI text string view or it is an audio player string view or whatever. He just knows that this thing will show a string, a value of a string somehow. And this way you can abstract a lot of the UI. So I created UIs that you can take, I don't know what I put as a drop down, and you can transform it into, I don't know, input field or whatever you want. This is some logic that I did to abstract interfaces. Then we started going to the real meat of this plugin. So let's start from the hands management. So we have some scripts to manage the hands. So hands are managed via XR Interaction Toolkit, a XR Hands plugin. So I didn't have to work in tracking the hands, luckily. So I created something on top of them. So what I did is, what I needed to do is trying to find a reference system from the hand. So what it does mean. The moment I do this gesture of grabbing this button with my pinch, the question is, what should the bottle follow? So I have this collider, it's being pinched by my hands. What is the reference system that this bottle, this collider, this whatever should follow? So that's an interesting question. Also, when I put an object in the scene, as I said to you, oh, I can do this and put an object in the scene. Where the object is put? Is it put in the palm? Is it put here? Is it put following the ring finger? Whatever. So we need ways to calculate a reference system out of a hand. And again, you have an interface, you have a base class, which is implements interface, and is a mono behavior, probably. No, in this case, it is not. But usually the base classes are. And then you have different ways of calculate a reference system. So the grab, the pinch and reference system calculator calculates the reference system when you're pinching something. So you taking it between the index finger and the thumb. Then you have the grab hand reference system that is meant for when you grab with the whole hand an object and then you release it. And the single joint is when with just one joint, maybe the index fingertip, you can calculate a reference system. In this case, the reference system is just the tip of the finger, of course. So you have different possible strategies to calculate a reference system out of a hand. And I wrote three, you could write other ones. Maybe you can write the reference system of this gesture. We will see in a while it is so important. So the reference system is made like this, and it will be shown then. I will show some examples when I talk about demo scenes. That is probably where you will start developing. You have also this presentation thing because again, model view presenter, and you have some debug way of showing the hands and its reference system. So I created some logic that, for instance, if you're doing pinch, you will have the reference system here, and you will show three tiny axes that show you where is the reference system. And you will have some spheres that show what are the joins used to calculate this reference system. So I created this presentation material, which is meant especially for debug uses. You don't have to use it in production, most probably. But when you're testing, when debugging and developing, I suggest you to use it. Then you have the objects placement. Objects placement is what about placing the objects in the scene. So for me, placing is literally saying, oh, I have this physical button, I do this gesture, and I say, put a collider here, because here there is a real element. So it's a way to place, let's say, the virtual elements where the real elements are. And there are a lot of classes here. That's been probably the most complicated part of the system for me. So you have again a presentation, and this is mostly to show the UI through which you can place objects. You will see that when I will show the content of the headset. You have a UI here, you select, I want to add an object, it's here, I want to add another object, it's there. And so I created these classes with all these, the management of all these UI. Then you have the placeables. The placeables are the objects you can place. Again, interface, base class, and then two types, basic and composite. But the logic is a placeable is an object you can place, is the famous collider you can put in the scene. The basic version is just an object can just be placed. So it's like I have, again, the battle, sorry to showing the battle so many times, and it's basically a cylinder. So I create a placeable which is a cylinder with a cylinder collider, and I do this to put the collider around the battle. So that's a basic one. The problem is I cannot interact with the basic placeable. It's meant just to show, to tell where is the object. Then you have the composite. The composite actually is made by two parts. The part that can be placed and part that is interactive. The difference when you use the basic or the composite is that if you use the basic to place the object, when you have to interact, you have to spawn another object. With a composite, you can use the same object to be placed and to be interacted with. Of course, they have pros and cons, both types. I made a sample with both, so you can evaluate which is better. So the placeable is literally just this, let's say this collider, I'm simplifying a bit, that you can put in place with just use your hands. Then you have the placers. What are the placers? Again, the face, base class, etc. In this case, I just create one, a hand pinch. The placers is like the hand that can put this collider, these placeable objects. So if the placeable object is the cylinder, the placer is my hand that does this, to place the cylinder. So one is the object that is placed and the other is the tool that places. So this is what is the hand pinch object placer, is the thing that is able to let you place object this way. And then we have the last one, which is the interactions. I developed a little interaction engine. One thing that I'm thinking about is if it is possible to, instead of using my own engine, to use it, I don't know, Meta one or the Metas one or Unity one or whatever. But for now, I just created my one. It's very simple to create a system of this type. And I guess you've seen already some interaction plugins. There is always interactable and interactors. Interactors are the objects that can interact with the elements, so the hand. You have the hand can interact with various objects in the scene. And then you have the interactables. And the interactables are the elements that are in the scene and you can interact with. You can see that the structure is mostly controlled by the interactables. In fact, there are more types. The interactor just cares about understanding who you are interacting with. But then the logic is all in the interactable side. Then there are three types of interactable I've defined. One is the grab. So I do this, I grab the object, and then I can move it around. So the interactable attaches to the reference system of the hand. There is a slide which is similar, but it can move only in some directions. So I grab it, but then I can only move it up, down, left, or right, or whatever. So maybe I can move it only up and down. So it's sliding just in this direction. The touch instead is the classical poke interactable. So you can touch it to make an interaction to happen. These methods have also the representers which are meant for debug uses. And then I also created a helper function that's called hand interactable color changer that lets you change the color of an interactable depending on its status. Because an interactable can be basically in three statuses, as you will see, and the class that manages the interactable doesn't implement any visual logic. Again, to separate totally the logic from the visual. And then I created this helper script to attach to the events of the hand interactable and change the color of the object depending on the status. So when you interact with it, it can become red, for instance. And this is basically the overall structure of the project. And something that I may also mention to you is some dependencies. I used URP, I used AR Foundation because I wanted this to be the most cross-platform possible. So it's not made with Meta plugin or Pico plugin or whatever. And then TextMesh Pro, which I used a lot for the UI, and various open, and also added the OpenXR Meta extension so that we could use Meta scene understanding inside our foundation. So that's very important to use. And basically that's it. So this is the overall structure of the project with kind of good details about all the scripts that are all very, very, very commented. I didn't write the tooltip of the parameters. Maybe if I get some donations, I can also invest some time for that. But everything is very, very, very commented, so you can really analyze how things work. And also, as you can see, I structured everything in a modular way so you can navigate easily into the project. Now, let's start digging into the demo scenes. So let's start from the first scene within the sample, so you can find it in the scenes folder of the plugin. And it's the hand visualization sample scene. So let's start here to start showing some concepts. I will not run this scene because basically you will see his effects already in the placement scene, which I will show you. So here you don't have any placement or interaction logic, but you have the reference system logic. So you see that anyway, I initialized all of these with AR Foundation. So there is the XR Interaction Manager, there is AR Session, AirPlay Manager, etc., etc. And this is standard AR Foundation stuff. And then and also with the hands taken from the sample that Unity kindly has given us. And you see that there are these elements. These are all reference system attached to the hand. So this one, for instance, calculate the reference system of the left hand using the grab logic. Grab is about the palm joint. So the orientation of the palm joint is the orientation of the reference system. Then here you have the pinch, which is the reference system which is centered in the place which is in the middle between the index and the thumb. So you can put something which stays always has been grabbed by the two fingers of the hand. Then here you have a right hand pinch with scaling because the if you notice here, there is an affect scale parameter, affect scale linear, affect scale known. And the fact is that the pinch is one of those gestures where you can also specify scale depending on the distance between the fingers, like you do when you swipe on your phone. So this can be useful. For instance, you put an object, as I said before, I want to show what's the size of this bottle. I do this and it takes this size. So I can scale the bottle size using my fingers. So this is very cool. Sometimes I may need it, and so I put the scale as something. Sometimes I can just not need it and put the scale as none. And because maybe I just want to move an object and then I don't need the scale. And then there is the single reference system. So here it is the right hand, the tip of the little finger, and it will have a reference system attached here. So you have, together with this reference system calculator, we just do the logic to calculate a reference system depending on the pose of the hand. And then you have this percenter. These percenters, as I told you before, are just for visualization for debugging. So the moment you go in production, you should disable it or remove them. And you can do that totally safely because they are not part of the logic of the application at all. So you can keep them in case you need them, or you can remove them. So this is the reference system thing. Now we will go into looking more into placement, and I will also show you the effect of the reference system on the placement. So let's start digging into the hand placement sample scene, which is the first major scene of this project. Most probably you will modify this to use it inside your application. So placement, I repeat it again, is so you have a real object and you say I want a virtual element around here. So you place, let's say, the physical object in your virtual world. Actually, you don't necessarily need to have a physical object. I thought it for that, but you can just even add virtual interactive elements in the scene with your hands, placing it. So this tool can also be used to put elements in an easy way into your virtual world. But let's see how this thing works. You have what I showed you before, XR Interaction Toolkit, AR Session, XR Origin. If you are into AR Foundations, these are standard things to have pass-through, to have hands interactions, etc. But then we have something a bit different this time. So let's start from what I described to you before. On the XR Origin, I put an R-Plane Colliders Manager. This is because during the placement, I want to know where there are the planes of the objects in the scene so that I can place the objects better. So you are seeing here in the game window that this is part of the UI that you can use in the placement procedure. And there are two options, align with planes and avoid plane scope penetration. What is it? So I imagine that the person that is doing the placement has done the scene setup inside the MetaQuest or equivalent procedure or another headset. So I know where are the desk, where is the floor, where are the walls, etc., etc., etc. If I have to put an object that is on the desk, for instance, I want to make sure that the collider I put maybe doesn't trespass the desk. Or if the desk is like this with this normal, I want to be sure that when I put the object with pinching, it is not put as an oblique object, but is put perpendicular to the desk. So knowing where are the planes lets me put the objects in a better way. And the planes are detected with the scene setup on a Quest. If you're using AR mobile, maybe you have just planes detection, like ARC or ARKit have these features. And to do the operations that I need to do, I want to have colliders. So Where you put your desk, where you mapped your desk in your room, I want to have a collider there. So I can put the object on it and avoid it from trespassing it. That's why I put a airplanes collider. In this case, I created a version with a local collider. What it does mean? So basically, in this moment, unluckily, if you use OpenXR uh, and not the Meta Oculus Meta whatever plugin, you cannot have the room setup inside Unity. So if you're using MetaQuest plugin, basically you can press play in Unity and have the data from the plane selected by the headset. If you use OpenXR, this doesn't happen. So what I do in this case, I put a local collider in the scene, this one, which is a cube, and I say to the collider manager here, saying this collider is like an additional plane. This way, in the editor, I use this cube to make tests, while when I run it, this is not counted as a collider because I flagged this editor only thing. This is just something I did for testing. If you don't need this feature, you can just add an Airplanes Colliders Manager and avoid all the mess. So you have to map which is the plane manager and then a few parameters. You can also choose to visualize the planes. So in this case, in this demo scenes, I left a lot of debugging stuff. So here I put like the renderer on this plane, so there's not only the collider. You can uncheck add renderers to not show them in case you don't want. So now we have these colliders and that's fine, but we still need to do stuff. And how to place the object with the placement manager. The placement manager manages the placement of the objects. And to do that, it needs an object placer. The object placer, as I told you before, is the one that actually put the object. So in my case, the only object placer is the one with a pinch. So I use the index tip and the thumb tip to define where is the object. And then I put it in the scene. So I keep doing this gesture to put various objects in the scene, and the placement manager keeps an overview of everything that is happening, everything that's been placed, and eventually saves it to the data storage. And it will save it by serializing it. So this is all nice. And which are the objects that you place? So there is, you can specify a database. In this case, I created one, items to play database, where you can give a name. I also put some sample objects here. You can give a name to the object. You must give a unique name because this is what will be serialized. And then you have to specify in this database what is the item you're placing. So in the case of simple placeable, as I will tell you before, the placeable item just contains the placeable. So this is the sample of the cube, which is a cube. I put a sphere to identify where is the top and have a better reference system. And I will show you in a while what are the handles. In the case of the the cylinder, instead, I have the composite. So you see I have a placeable part, interactable part in the same object. You see that the cube that is simple has an associated spawnable item. The spawnable item is the one with the interaction. In fact, this is an interactable cube. So what the object placement manager will do is that it will let you spawn, it will let you place these objects. A cube grab, a cube slide, a cube touch, and a cylinder. When this thing will be loaded again, so you can save the setup you did in the scene, and when it will be loaded again, in the case of the of this simple placeable, when you finalize the placement, they will be transformed into this one. So you end the placement moment with a finalization, and you have the interactive object. When the composite, you have no spawnable because the composite itself becomes the interactive thing. So when you will modify the project, most probably you will create this placeable, this interactable, and you will go to modify my own uh, scriptable object asset here, or you will create your own and you will assign it to the hand-based object placement manager. So I have still a few things to say before going to the demo. So you have the end placement menu activation, which shows a UI that you see when you look at your left hand. So the logic is that with the left hand, you place the object and then you confirm it on the menu that is on the left wrist. And here you have a lot of UI that manage the placing, the saving, and the loading of the elements because I let you place the objects, save them, load them into your scene again. This is very, very important. These are all presenters as before. So there are lots of UIs which call methods basically of the placement manager, of the placer, or the data storage. The data storage is to save and load the setup of the object. As we will see during the demo, the save and the load of the objects can be done referring to specific planes of the scene, which will let us create some very persistent setups of placement objects. And this is the basic structure. If you are interested, here also there is the presenter you can disable if you don't want to show the bug info. You should, as I said, probably disable also the local collider. I'm going to remove it here in your scene if you don't want it to be there. So you can put 0 here and disable it. And the UI, you can create your own if you want, or you can keep this one. It's good in both cases. So, one last thing which is very important, how it is made a placeable object? Well, a placeable object, let's take the cube, is basically an object with a collider and a placeable object basic or composite element on it. The placement object basic will also let you specify some colors, so you can change the color of some renderers depending on the status of the placeable. So you can see what is the status of the operation. But what is super important of it are the handles. Every placeable object should have two handles, which are added to here, to the object handle of the basic and composite elements. What are the handles? Basically, the thing is you are pinching this element. So in a way or another, you are going to do this to say, I want the collider to be this. But so you need, when you write this element, to say, but when I mean this virtual element, where are the index and the thumb supposed to be? So in this cube, you see that I put the index and the thumb of the two extremes. So the moment I do this, the system will draw a cube around here that will go between my two fingers. If I put the handles on top here, when I do this, actually the cube will have started here and went down. So the handle is like, where do you handle this collider, this placeable, this virtual element with the index and the thumb? And you have the index handle and the thumb handle. And it's very, very important to specify them in the right way because they give you the reference system of the placeable. So, summarizing, if you want to do your own placement, I suggest you to keep the same UI, you keep the same data storage, this saves on the player prefs, and the same placement manager with a pinch of your placer. You can select left or right if you want. Remove this debug UI with the presenter here, remove this local collider here, and in the airplanes colliders manager, and then go to this item to place database, put your own objects and substitute my objects, my sample items with your ones. Look at what I did in the sample, you should be able to do something of your own. Then you can build this scene and obtain what I will show you in a moment. The moment you build this scene, you can place objects and you can save the setup so that you can load them in another scene. So one last detail is that in this moment, I created two separate scenes for this. And in this exact moment, you have basically to build once the application to the placement and then build it again to use the everything. This is because these are sample scenes, just to prove concepts. You can, for instance, take the moment when there is the finalization, so register to the events of this button, the finalize placement. And when the finalization happens, you can, for instance, load the scene after. Or when the finalization happens, you can activate the interactables. So you can do many things to avoid this very clunky way of working. Probably I will also refactor the project in the future to already give you scenes made in this way. But in this current version, it is not like this. So I know it's not ideal, but this is how things work for now. You build the scene, you do the placement, then you build the other scene, and you use the application. But this can be changed rather easily by registering to the events of this button. And now let's see what happens when I launch this one.
So here I am inside the build of the application that has the scene that I was showing you before. And you see the scene mixed reality. All this light blue you see is because I specified to add a renderer with this light blue to the plane. So I see the desk as this little plane colored with azure, the window as well, etc. You can remove the renderer as I told you before, and you can obtain uh, something which is less disturbing, let's say. But I wanted to show you. And this is the interface. So you see if theoretically when I look at it, it appears and it lets you specify what you want to do. So here there are the elements you can add to the scene, are the ones I said before. Here you have the options. Align with planes lets you align the object with the plane, with the collider of the plane. It's normal. The avoid planes compenetration prevents you to put something that enters into a collider. Here is the button to place a new object. And here there are the objects to manipulate everything. So let me show you. I can add a cube grab. So place new object. Sometimes they are not easy to press these elements. These are the standard ones by the external interaction toolkit. So this is not my fault, let's say. So you see, I move the pinch and the objects stay between the pinch of my hands. And I use the left hand so I can use the right hand to confirm. So since I put a line to the plane, if the objects touch the plane, it takes its normal. It can be horizontal or can also be vertical if I do that on the wall or on the window or whatever. Then, since I avoided compenetration, even if I try to enter into the desk, I cannot. Of course, if I go really down, at a certain point it lets me do it, but for now, it's cool this way. So let's say I want to put this object here. So I just do confirm, and I put the object. You see, it was red during the placement, now it's white again. These are the meaning of the colors you can specify. I can put others, so I can have a grab, and I can have the cube touch. So the cube touch, I show you what happens if I don't align with plane. So let me disable it. I place the new object. This is the touch. You see, I can put it in the whatever orientation, even close to the plane. So let's put it a bit like this, confirm. And now realign with plane, and let me put the cylinder, for instance. If the interface lets me select the cylinder. Okay, place new object, and this way. So the cylinder is a grab one, by the way. So I can manipulate the object, like I can remove all, I can remove the last one. So I don't like the cylinder there, so I replace it and I move it floating one. Let's put it like this for some reason that I don't know. Okay. And then I can save and load current setup. So I can save. Sorry, this is a bit clunky. And here it's very important because I have some save slots which are transformed into different player paths. If you use file for save, this can be different files. I select the slot one is fine. And then it's very important, the reference plane. So if the reference plane is none, the absolute position of this object is saved, which is fine for most cases. But if you save this setup, then you turn on the headset again, it may have a different origin. So the objects you put here may appear here, which is not good. So if you have done the room setup, you know where is the floor, where is the desk. So it's better if you save them with a reference system. In this case, since they're close to the desk, I will put table. I put a table here in my scene setup, and it means that the position of these elements will be saved relative to the table. If I turn off the headset and turn it on again, it will redetect the same table, and so will put the elements in this exact position again. So I select table, object slot, and then do save. Now, just to show you, I can remove them all. I can do load. It asks me from where, and I say load, and add here again. Even if I turn off the headset, they will just show in the same position again because I put it relative to the desk. After everything has been done, I can finalize the placement. So when I finalize the placement, you see the cubes have fallen down because they have a rigid body and they just went down, while the cylinder is here, but with a different color because it's changed from the interactive object to the from the placement object to the interactive object, and the cube. But it stayed the same game object. Well, the cubes transformed in two different game objects that were spawned in the scene and they fell down because of the rigid body thing. And that's it. So what you can do, as I said before, when you do finalize, you can create an event that when you do finalize, it shows you the interactive objects and you add interactors to the hand so you can do everything in the same scene, or you can load the other scene. You can do many things. So this is just to give an example, but this is the sample UI. And just one little thing, you see this tiny thing here, that's the reference system. This is the debug thing I was saying you before, the presenter of the reference system. You see I have the 3 axes that depends on the pose of the index and the thumb fingers. And it increments inside when the gram more distant because it has scaling. And these are the 3 points I use to calculate the reference system. And this is how I place the objects, because the objects are connect to this reference system and put their scale so that to fit with the handle, the thumb, and the index. So this is how this works. So you have seen how it is easy to place objects because I can keep placing objects. You see, I just move my hands and I say confirm. I place a new object, confirm. It's very, very, very handy. So I did everything this way, and then I can even say these 2 new objects in another slot if I want. So I did everything. So now let's see what happens when I want to go interactive.
And now it's the turn to see the last scene, the hand interaction sample scene. So after you have placed these objects, you can load them into scene and interact with them. So again, it's very similar, XR interaction toolkit, XR hands, blah, blah, blah. I still kept the planes collider because it can be good to have some colliders. There is the menu like before, but I disabled a lot of things. Only the load is enabled. It's slightly different. It's a variant, in fact, as you can see, because this one just lets you load and finalize, while the other was about saving, placing, etc. There is the placement manager, but it's still only used to load. In fact, there is no placer because the placement manager can save and load placed objects on the data storage. Then you have, in this case, I put a floor. The floor is just, again, for demos inside Unity because you saw that or this rigid body that fall down. The problem is that in the Unity scene, you have no way to have colliders on the plane, so I put a floor collider to prevent them from falling down. And then you have interactors. So you may say, where are the interactables? The interactables are here. It's what we generated before, from the database. So if you take the simple interactable cube, it's a mesh renderer, a box collider, and a hand grab interactable. A rigid body, and that's it. So there is a debug element that you can disable if you don't want it. It tells you who is interacting with, etc. That's good for debug. You can remove it whenever you want. Again, press enter so you can remove it. Nothing changes. There is this interactable color changer that is used to change the color to show the state. This is even not necessary. I mean, it's something you can do to show the user what's the status of objects, but you can even just get your logic to register to the events of the interactable, because something that the interactable does is having an event which is called something like sorry, it's on the I hand interactable, if I'm correct. There is an action somewhere that it was there. So action interaction state changed. So you can take the status of the object for an interaction state changed and do something. So there are three possible states for an interactable and for an interactor. One is non-interacting, obvious. One is interacting, and that's obvious again. So it is a grab interactable, it's grabbed. If it is a touch interactable, it's being pressed. And then there is the interaction possible, which is a strange name I created, which is about the interaction is potentially happening, but I'm not so sure yet. I want to wait some time to see if this is the case. So how does it work? Why there is this state? Because the hands move a lot, and basically, if I have a virtual collider around this button, maybe I just move the hand here while I'm moving it, and I don't want that. If I do this by chance, I grab the object. I want the grab to be confirmed for some time. So we will see very soon how the grab works, but the idea is that it works via colliders. So if the colliders of the interactor are interacting for, I don't know, 1 second, 2 seconds, 10 seconds with the same collider, then interaction is happening. Before that time, the interaction is possible. So consider it as a pre-interaction, as a hover in a way, but you're still not interacting. So that's the three events about interactable and interactors throw. And then here, it's another interesting thing. When you create an interactable, you have to specify the minimum interaction points. Why this? Because you have interactors even with just one finger, because you can use the index like to press objects, but you don't want to grab with the index, also because you have no way to detach the object. So you can say that the grab interactable, for instance, has two minimum interaction points. So it needs at least two fingers to be interacted. And so if you poke with the index, nothing happens. Interactable, as we saw, there is the grab, there is the slide, there is the touch. And they're quite straightforward. The touch has even almost no logic because it's just made as an interactable, and then you can register to its event to do something. The slide is like a grab, but I put some freeze for the locations and rotation so that it slides only on a plane or on a line. Basically, you can copy this. It's very easy. We create collider, maybe rigid body, maybe not. It's not necessary. You put a grab interactable, touch interactable, or whatever interactable you create by subclassing an interactable, and you have your interactable. And interactables are generated dynamically into the scene in the position you saved when you place the object. So the idea is that you place a bottle here, and when you launch this scene in this place is put a collider that is interactive. So you can grab this collider when you grab the bottle and you have this interaction. In the scene, you have also the interactors. I put three. You can just take whatever you want. You can have just one. I just put three just to give you examples. You can even just have only the pinch, for instance. And what happens is that you have, again, at the bug UI, you can remove to not see the stuff. And then you have the interactor, which has a reference system calculator. As we said before, it needs to know what's the reference system, because when you interact with something, I want to know where is the hand so that I can move together with the hand. And especially for the pinch, this is very important because moving the fingers, I move the bottle, but I also have to move the virtual reference system. And you saw it in part of the video before, moving the fingers was moving the reference system. Then you have a presenter that you can disable this just for debugging, and then you have this hand interactor script. The hand interactor script is basically one is a hand interactor where you specify the collider's diameters, because how does an hand interactor works? It has some colliders on some joints. When all the colliders collide with the interactable object, the interaction is happening. So for the pinch, the two colliders are on the fingertip. When the two fingertips enter the collider of the bottle, the interaction is happening. As I said, there is some time before the interaction starts, and there is also time before the interaction ends, because I told you that the tracking is a bit glitchy. So I don't want that sometimes the index tracking has a glitch and I don't grab the bottle anymore. I want to make sure that I stop grabbing the bottle only after this non-interaction is confirmed for some time. And here the diameter specify the diameter of the spheres added to the joints to verify the collision. So you have seen that there is an interactor and then there is this an interactor custom joint colliders. It's basically the same thing. The only difference is that this one puts the colliders in the joints used by the reference system calculator. So here I have the reference system on the index tip, and an interactor will put a collider on the index tip. While these ones say, I don't want to use the one of the reference system calculator, I want to use my own colliders. So in the case of the palm grip, I verify that something collides with the palm and with these two parts of the index and the thumb, not the tip, to not confuse it with the grip one, with the pinch one, but these internal parts. So when I grab something, it touches these three colliders and it's part of the interaction. If I just use the one of the reference system, probably wouldn't be good. And for the pinch, the fact is that the reference system uses three joints, actually. I want to use only two. That's why I use the custom joint colliders. Again, you can do whatever you want, check out the code and create your own colliders, interactors. Notice that interactors are exclusive. So if interactor A is interacting with object A, interactor A cannot interact with other objects, and interactable object A cannot interact with other interactors. So the moment that someone starts interacting, they ignore all the rest. And basically that's it. So this is how this scene is structured. Now I will build it for you. And again, I will show you how it works when it's inbuilt. Again, just a reminder, how do you customize it? Very importantly, you customize the database by creating your own objects that are interactable. And then here, basically everything is done. You have to just select which interactors you want to keep, create your own one, and the rest works out of the box. If you want to keep my behavior, of course, everything can be customized. You can check out the code. Everything can be customized. You can create another UI. You can do whatever. But that's it. Let's go see what happens inside the headset.
So I've built the scene of the interactions and I obtained this. So now I disable the blue for the planes, and you see I have this simplified UI that lets me load from the slots. So I can select the slot and I can click load to load the objects that are in the same pose as before. So uh, notice that these are still not interactive. And the idea is that you can see what you have in the various slots, maybe, and then finalize only when you have the right one. If you modify a bit this UI, you can obtain this behavior that you select the slot, you see what's inside, and you finalize only when you are the right ones. The idea is, anyway, before you finalize, you can put the objects, the real objects, where the virtual ones are. So I can put like the bottle where there is the cylinder so that I can interact with both of them. In the hands, you see that I kept all the three interactors. I keep this debug interface. You see they have three reference system on the palm, on the index finger, and the pinch one. And this is just all the bug stuff that you can remove. I now have just to say that I want to finalize this placement because I like it. The cubes, as usually, fall down because I kept the rigid body, but the colliders generated here are trigger ones. So if you want, you can use the AR plane manager and add real, let's say, not trigger collider for the planes, so the cubes can fall on the desk, for instance. And now what I will do is try to put the bottle inside this virtual one, and now we'll try to pinch and grab the cylinder and grab also the bottle at the same time. So you see more or less when there are not glitches due to the bad tracking of these, the real and the virtual bottles stay more or less aligned. But this is, as you can see, not always true, and especially now I'm in artificial light, it's even harder. You see, sometimes there are very bad glitches with the detection of my finger, which is not accurate, or because, as I said before, I move slightly how I keep this in my hand and the tracking is lost. But more or less, if you want to put maybe some clouds floating over it, it's fine. And then I can do this, and then I can open my finger, to leave it again. So I can grab it. You see when it's the chan is interaction possible, and now the interaction is confirmed, and I'm moving both. Then I open again, and it's now, after a few seconds, it's not interactive again. As you can see, the problem is the moment you have disaligned the real and the virtual elements, basically the game is finished. But this is something that, as I said, it's important to work on and to wait also for the hand tracking algorithms to be better to avoid this from happening. But from some simple things, I've noticed that you can already do some very nice experiment with this plugin, even at this stage. So with this virtual cube attached to my hand, I say that the experiment is over, and now it's time for you to do your own tests.
And that's it. So if you have arrived here without having fallen asleep, you are a hero. Compliments to you. And I hope the video was interesting to you and you want now to do something with these habit and interactions. I'm really curious if you get something out of it, let me know. And just as a reminder, again, this is an alpha. I created these foundations, so still a lot of work to be done. And maybe before even something like that is perfection, companies will add object detection to the headset, so this will become maybe useless, or maybe still the placement thing with the placing can be useful because it's cool. So In any case, thanks for watching this video. Thanks for the interest in this project. Have fun with it and enjoy your day in virtual reality with hybrid and interactions. Have a good day. Bye bye.